I'm Chris Woldridge, Dorsey sales engineer. My role is to work with designers, consultants, anybody in the design phase of projects for Dorsey for every product we have. And if you don't know me in person, you know me by all the annoying emails about the Power Hour. It's kind of my pet project for educating our engineering and contractor community in the Pacific Northwest. Today we have Morgan. She is going to be presenting on louvers and understanding the basics of performance and selections. The couple housekeeping items, I do have everyone muted. Please put questions in the chat. I will monitor and interrupt Morgan if needed, or I might just hold it to the very end. And then the shameless plug for all of our other sessions. Next week, we do have kitchen ventilation systems presented by our own Ryan Stewart. So that'll be a wonderful, and you can always go back and re-sign up if you change your mind and you want to sign up for more sessions. That's not a problem. We can do that. So with that in mind, Morgan, I'm going to hand it over to you and let you introduce yourself.
All right, thanks so much, Chris, and thanks for having me. Hi, everyone. My name is Morgan Workus. I am an application engineer with Greenheck Louvers, and I am thrilled to talk to you all about louvers today. Can everyone see my screen?
I can see it on my end, so I think you're good.
Okay, awesome. Oop, make sure I'm on. There we go. Okay. So before I get too far into this, I'd like to quickly introduce you to the Greenheck Louver team. Again, my name's Morgan Workus. I've been at Greenheck for 7 years, working in our louver division in various roles, such as production supervision, manufacturing engineering, and most recently product development engineering. While I just joined the applications team last June, it's been about a year. I've had the pleasure of working with our Louver product and the gentleman on this screen for several years. Andy is our amazing product manager, and then Todd and Paul are my partners. We work to help contractors, engineers, architects, people like you guys, and we help them select the very best product for their projects. And between the four of us, we have, I believe, over 80 years of louver specific experience at Greenheck. And we are so happy to assist you with anything you may need. Greenheck Louvers has approximately 230,000 square feet of manufacturing space, all located in the continental United States. We also look forward to expanding our manufacturing footprint to our incoming Knoxville, Tennessee campus in the upcoming years. We're super excited. A brief overview of our agenda. I anticipate this to take maybe 45 minutes, and I am really excited to hear what questions you have. First, we'll go over louver performance review. We'll talk about testing, blade types, how that impacts performance, horizontal versus vertical, all of that fun stuff. We'll touch a little bit on severe duty louvers, really focusing on wind-driven rain. I'll briefly brush on hurricane and FEMA storm shelter louvers, just so you know if you need them and you know that we have them. Not going to be a huge focus today. And I'll spend quite a bit of time on, accessories, drawings, and information. If you need structural supports, general installation information, and I'll finish up with EPDs. So, what is a louver? A louver is going to be used when we want to allow air to enter a building, but keep out weather elements such as rain. Louvers can be used for intake or exhaust, but we also see them sometimes used merely for aesthetics or equipment screening. A fairly frequent question we get is, what is the difference between a louver and a damper? So I added this slide to some of our presentations. Louvers are going to typically be on the exterior of the building, while dampers are typically going to be on the interior of the building, usually in the ductwork. This is not an end-all be-all. It's just very generalized. Both will manage airflow, and dampers are more going to focus on managing any like fire or smoke or anything a little bit more specific in that airstream in the building, whereas louvers are going to mostly manage water ingress on the outside of that building. The reason louvers and dampers get confused pretty often is all dampers open and closed, but louvers also have some product that will open and close. This last part of the chart is a little more Greenheck specific, I think. All of our dampers are going to have AMCA air leakage classifications to them, whereas a Greenheck louver that is operable will have air leakage data available, but it is not AMCA classified. But most importantly, the main difference between a louver and a damper is ours are prettier, typically. Going back to biology class, we can talk about anatomy of a louver. The top frame member of a louver is always called the head. The bottom frame member is always called the sill. The side frames are called jambs. And then louver blades can be horizontal or vertical. Sometimes a louver will have both contained in one frame. And we'll talk about the performance of each of those types of blades today. But before I get into any louver product or testing, I want to just tell you about how we name our louvers. That way, when I'm spitting louver names at you during this presentation, you're a little bit more comfortable about what kind of louver it might be. So most of our louver product is going to start with the letter E. It stands for extruded aluminum. We used to do more sheet metal louvers. However, in recent years, I think about 2 years ago, we took a look at our product offering and really wanted to focus on what do we do best. What we do best here at Greenheck Louvers is extruded aluminum. So most of our product now will start with the letter E. The middle letter is normally about the application of the louver as a whole. An S is going to be a stationary, a C is going to be a combination louver damper, A would mean adjustable louver. And then that last letter is usually more about the blade itself. So D is going to be a drainable blade. An H is going to be a high-performing wind-driven rain style blade. It's going to be like a chevron shape. A K would be a K blade, so on and so forth. And then the first number is always going to be the frame depth. So if a louver starts with a number 6, it's going to be a 6-inch frame. If it's a 4, it's going to be a 4-inch frame. And then the last two numbers are typically one of two things. It could be the version of louver, 01, 02, 03, etc. Or it could be the pitch of blade. So as our example here shows that ESD 635 has a 35-degree blade. Sometimes you'll see a Greenheck louver model with a letter at the end. The most common is going to be the letter D. That means it has a Miami-Dade notice of acceptance, meaning it's a hurricane-rated louver. Another common one is going to be an X model. So if it ends in the letter X, it's going to have a Florida product approval. For your applications with your location, it may be used as a high wind load louver. All right, let's talk AMCA quick. AMCA is the Air Movement and Control Association. They have several tests for louvers that we'll discuss today. So what kind of tests do they perform? You'll see the varying tests noted in the blue and yellow stickers on each louver and its submittal. These blue and yellow stickers signify that these have been tested by the AMCA 500L. It's kind of an a la carte situation, the AMCA 500L. You can kind of pick and choose which tests in that set of tests that you would like. It could just be water penetration and air performance. Sometimes you could select sound performance. You could select wind-driven rain. You could select maybe sand, whatever you would prefer and whatever that specific louver's application is and what makes sense for it. With the AMCA 500L, the test specimen is always 48 inches by 48 inches. So a lot of data that you see is based on a 48 by 48 louver. And the AMCA 500L is not a pass-fail set of tests. It merely gives classification and data on all of the different louvers that it tests. And we'll talk about why that's important when we talk wind-driven rain. So how can you be sure that the performance is stated accurately on a submittal? If no test licenses or certifications are noted on a submittal, you cannot be sure. But if you see an AMCA certification noted, you can be confident that data on a submittal is accurate and proven, and then you can feel a lot more confident using it as kind of an apples to apples comparison across different louver models as well as different louver manufacturers. So what is free area? We here in Louvers like to joke that free area is the area we don't charge you for. It's free. But the more widely accepted definition is The free area is what is left after removing all of the obstructions to airflow. So the blades and frame members of the louver are going to restrict that airflow. Sometimes we see face area and free area confused. So face area is going to be that hole in the wall. So whatever I'm installing my louver into, that entire hole, the square footage of that would be the face area. We in louvers are looking more at the free area of the louver, how much air is going to be able to move freely through that louver. And that is going to be the face area minus all of the obstructions like the blades and the frames. So the AMCA 500L test uses a 48 by 48 specimen. So when you see a percentage noted, please only use it as a method of comparison across models and manufacturers at 48 inches by 48 inches. The square footage of the free area should be used at the louver's specific size. Very oftentimes we see louvers specified for 50% free area, but the louver might be scheduled at, say, a 12 by 12 or a 12 by 18, and there are no manufacturers on the market with 50% free area at a 12 by 12 louver because the frame members take up so much space. You're not going to find a 50% free area at a 12 by 12 louver. So you'll see on the chart that the size of the louver greatly impacts the free area. The AMCA 500L also tests the louver's resistance to airflow. Again, 48 by 48 test specimen. The pressure drop charts for each louver are found on each louver product data sheet. Here at Greenheck, we call the data sheets static submittals. It'll have a bunch of information and charts for a 48 by 48 louver. What we call a dynamic submittal would be what maybe you get from a rep or someone, and it has specific louver models and sizes on it. But these charts are going to be on our static submittals. You'll notice that there are separate lines on the airflow chart here for intake and exhaust. Sometimes on a chart, it'll look like it's one line. It is tested at both intake and exhaust. Sometimes it performs the same, sometimes it performs a little bit differently. The higher the pressure drop, the more resistance to airflow. The lower the pressure drop, the less resistance to airflow, leading to a more efficient HVAC system. We usually see specified maybe 0.1 inch water gauge as a pretty typical static. The louver's blade profile and blade spacing will directly impact the pressure drop. So here's a diagram to compare airflow through a non-drainable blade, kind of shown on the left here, and then it compares it to a wind-driven rain blade on the right. Very generally speaking, tighter blade spacing and more complex blade geometry is going to increase the pressure drop because there's more obstructions in the airstream. The AMCA 500L tests beginning point of water penetration as well. This is going to be the free area velocity at which a louver intakes a significant amount of water. Specifically, the point at which 0.01 ounces of water per square foot of free area is collected on the floor of the test chamber. I'm more of a visual person, so let's look at what that test looks like. The 48 by 48 louver is placed in what we call a wetted wall, where the water is dripping down the face of the wall and onto the face of the louver. Water is also going to be falling in front of the louver at a rate of about 4 inches of rain per hour. There's an intake fan behind that louver and it pulls air in, and then water goes with that air right into the louver. And this test mimics a decent rainfall, but it does not involve any kind of wind at all. So keep that in mind when you're looking at beginning point of water penetration. When's the last time you saw a storm come through or even a light rainfall and it had absolutely no wind? It's not as realistic as maybe a wind-driven rain test. This slide shows examples of the beginning point of water penetration chart that is found again on that static submittal. Here I'm comparing water penetration on a non-drainable louver on the left versus a drainable one on the right. And I also included kind of a side profile of the louver so you can see that the drainable louver has a drainable head and then all of the blades are drainable. It's got those little, like a little gutter to kind of direct the rain outside of the louver, whereas the non-drainable will not have that. The asterisk on the beginning point of water penetration charts shows where water begins to penetrate the louver. Again, that's at 0.01 ounces of water. Two things I'd like to point out on these charts. First is the free area velocity at which the louver starts to bring in water. The non-drainable louver brings in water at a much lower velocity. Might be hard to see on your computers, but it's about 690 feet per minute. The drainable louver, on the other hand, is going to bring water in at a higher velocity. We're looking at about 1,080 feet per minute in this specific example. The other thing to notice when you're comparing these charts is the slope of those lines. The non-drainable louver brings in water very quickly as the velocity increases, while the drainable louver continues to reject water at a high velocity. This comparison shows exactly why we would recommend a drainable louver for an intake application. Here I show the relationship between volume, free area, and free area velocity. When you're sizing louvers, if you know two of the three in this equation, you can solve for the other. So if you take the volume and divide it by the louver free area, you'll get free area velocity. So what happens if you only know one of the variables in this equation? Sometimes people only know maybe the free area or the volume. Let's say you only know the volume. There's a couple different industry rules of thumb that you can use here. The most common is sizing an intake louver for 600 feet per minute and an exhaust louver for 1,000 feet per minute. Another rule of thumb for free area velocity is 75 to 80% of the beginning point of water penetration. So if I have a ESD 403 Greenheck model, and let's just say that it has maybe a beginning point of water penetration of around 1,000 feet per minute, 75% of that is going to be 750 feet per minute, and I could feel very comfortable sizing the louver at that kind of free area velocity for intake. So we're going to use the free area velocity to find maybe pressure drop. If you don't maybe know the free area velocity, you could use this pressure drop chart to find the kind of target free area velocity if you have a specific pressure drop that you're trying to stay under. Same with the beginning point of water penetration. If you have a specific penetration rate you're trying to stay under, now you can find a target free area velocity to solve for one of the other variables in this equation. Again, I'm more visual, so I like this graphic showing it's that same equation, just rearranged. The air volume in CFM is equal to the louver free area times the louver free area velocity. So putting it all together, looking at a higher free area model, the ESD 635, might be hard to see on your screen, but I've got a 36 by 36 ESD 635, and I am throwing in 3,000 CFM for my volume, and its intake. The free area velocity is right in that sweet spot of about 600 feet per minute, and we have a low pressure drop. Now, if I keep that same size and I increase the volume to 4,000 CFM, I increase my free area velocity and I increase the pressure drop. If I keep that 4,000 CFM, but I downsize my louver a little bit to a 30 by 30, my free area velocity is now greater than my louver's beginning point of water penetration, and you are 100% going to get a call from somebody about water in your building. Couple things AMCA does not test. They do not test equipment screens for any kind of air movement. They do not test penthouses for beginning point of water penetration. There's just not a test setup that works really well for it. They do not test any kind of shaped louvers, and they do not test louvers with any accessories on them at all. We do have data on approximate performance for a lot of these types of product, but we cannot certify that performance through AMCA. That's going to be true for any louver manufacturer because there's literally not a test that exists. We have a variety of product to choose from, including non-drainable, drainable, acoustical, adjustable, damper louver combinations. We also have those penthouses and screen wall product, but again, notice there are not AMCA stickers by those because they're not tested by AMCA. Your reps at Dorsey are very happy to assist you with finding the perfect louver for your application. So now that I've given a basic overview of louvers and testing, let's look at louvers that are really great for more of a severe weather application. So when should wind-driven rain louvers be applied? Wind-driven rain louvers should be added when at any location where there are limited provisions to the effects of wind-driven rain, or if there's any equipment or anything behind the louvers that might require a little bit more protection in case water infiltrates, like any kind of electrical equipment, let's say. All right, so these pictures show from 2006, so they're quite old. However, they still get the point across, and we get calls like this all the time. Here's an example of a job that could have used some extra water mitigation. A non-drainable blade louver with a backdraft damper was used at a factory in Texas, and they encountered a severe storm over a weekend in 2006, and it flooded the entire factory. The factory was down for a few days while they worked to remove the water. And of course, the easy thing for them to do was pick up the phone, call up Greenheck Louvers, and blame the louver. But this louver was subjected to more water than its intended purpose. We would have recommended wind-driven rain louvers here, or at very minimum, a sill pan with end dams to catch some of that incoming water. So back to AMCA 500L, another test that falls under the AMCA 500L is for wind-driven rain. There are two different airflow and rain rates available for testing. One is going to be 3 inches of rain at 20-mile-an-hour winds. So if you think about it, that's a pretty mild storm, I would say. And then the other option would be 8 inches of rain at 50-mile-an-hour winds, which I would consider a bit more severe. So instead of rain falling in front of the louver, we now have water shot directly at the louver and a fan blowing the water toward the louver to simulate wind. The wind-driven rain tests are going to be a lot more realistic for testing how a louver will behave in rainy conditions. So one thing I really like to hit home when we talk about the AMCA 500L tests is that these are not pass-fail. The louvers merely receive a classification from AMCA, so anyone can get any louver tested for wind-driven rain regardless of its performance. There are several classifications for water rejection that AMCA assigns through the wind-driven rain tests. You'll want to make sure the louvers selected reject the majority of the water with that A classification. You'll find the AMCA wind-driven rain performance charts on any product data sheets or submittals for any louver that has been tested by AMCA for wind-driven rain, and I have an example on this slide. So I have an example on this slide of what we like to call certified poor performance. I found this on a competitor submittal a few months ago. It entirely made my day because it's hilarious. I want to point out the velocity on this chart, and it's 14 feet per minute. So I'm looking at the rainfall rate of 8 inches of rain per hour with the wind velocity of 50 miles an hour, kind of toward the bottom of the chart. Core velocity, 14 feet per minute, penetration class B, around 96.6 effectiveness. So let's think about what 14 feet per minute means. My imaginary pet turtle could walk 14 feet per minute. So the fan was barely on, and they're a B classification. So manufacturers with poor performing louvers are counting on you to not look at the data. They're counting on you to just look at the sticker. They're counting on you to pull up a submittal, say, oh, this louver is wind-driven rain, that's great, and select that louver. But it's really, really important to look at the data and how well that louver actually performs. In more perspective, we tested one of our high-performing drainable louvers for wind-driven rain. The results here show the drainable louver allowed a very significant amount of water through it without the intake fan even on. 0 FPM for that area velocity, rain rejection of 86%. We turned on the fan and went to 500 feet per minute. That's not terribly fast, and only 50% of the water was rejected. So we could go to AMCA tomorrow and get this louver certified for wind-driven rain, and this is how poorly it will perform. So on our wind-driven rain models, the blade is considered a chevron shape, and it has a rain hook at the peak of that chevron. All of these models are also going to be considered site-proof, due to the blade shape and the blade spacing. The EHH horizontal style louvers perform pretty well in the wind-driven rain, but have a little bit of a lower free area. And because of the complex blade geometry, they're going to have a little bit of a higher pressure drop. The EHV louvers feature a horizontal front blade for the appearance, but the vertical rear blade for performance. The vertical models are our top performers in wind-driven rain. They perform so well because water never has the opportunity to enter the airstream by dripping from blade to blade like it would on a horizontal louver. So when water falls on these louvers, it clings to the blade and then gravity is kind of working in our favor and that water just kind of falls down the blade and then egresses out the front of the louver. It just never has that opportunity to enter the airstream. They work very well. The vertical louvers also have a chevron blade like you can see here, but because it drains a lot better, we're able to remove a lot of the rain gutters and things of that nature. We're able to shorten up the rain hook, and so we're able to get a much better free area and a much lower pressure drop. So even with the kind of complex blade geometry that you see here, the vertical louvers are the most effective against wind-driven rain. One more thing AMCA does not test is going to be snow. So if you're familiar with snow, you know there are different kinds of it. You know, sometimes you have the dry, wispy, light snow. Other times you have a very wet, dense, heavy snow, you know, like the kind that would be perfect for building a snowman or having a snowball fight. The variance in the snow's behavior makes it extremely difficult to make a test standard for. So AMCA does not have a test for snow. So when we see snow infiltration through a louver, there are a few possible solutions, but very little data exists due to lack of an official snow louver infiltration test. One thing we see people do is use what's called like a snow screen, or maybe they'll put a filter, like a washable aluminum filter behind the louver, and it kind of catches a lot more of the snow. But I would caution that solution because the pressure drop is going to be a lot higher, not through the louver itself, but with the snow screen or the filters, it's going to be higher. Um, Another solution we hear people utilize is they just size the louver larger so that the free area velocity is lower. But you only want to do that so much because the larger the louver is, the larger the target is for snow to hit it. So while you might want to go a little bit lower on the free area velocity, you don't want to oversize the louver either. Another really good option is a weather hood, but not everybody loves the appearance of a weather hood. So the best we can typically do from a louver standpoint is to utilize a wind-driven rain louver. The tighter blade spacing and more complex blade geometry works best for mitigating that snow infiltration.
Real quick, Morgan, we have a
Yeah.
question since we're talking about ratings.
Mhm.
How does high altitude affect ratings and data? This person has clients up to 7,500 feet of elevation.
Yeah, I mean, so AMCA is not going to have any kind of testing for different altitudes. Um, I would think pressure may play a little bit into it, so you might just want to look at the pressure drop or any kind of pressure requirements through that. But again, we don't really have any kind of data on it.
Okay, well, we can always ask engineering if maybe they have something behind, but I've haven't ever seen anything in regards in my time doing this regarding elevation and mover ratings. So there's another
Mhm.
question here we can go ahead and address, and I'll handle this one. What are good applications for combination louvers as opposed to stationary with a control damper behind it? Uh, Personally, I think combination louver dampers are great. There shouldn't be any reason except our wonderful Washington State Energy Code that requires the class 1 low leakage. She pointed out on one of the earlier slides that they do have performance ratings, but they are not AMCA rated for those performances. So if you're potentially doing something in another state based on their energy code, you can probably use it. It makes for a really simple installation where it's not multiple components or it's not a sleeved component that's a little longer. I've worked in other parts of the country as a Greenheck rep. In the EACA, a combination louver damper was extremely popular on warehouses. because it combines the louver and the damper in a simple assembly. So that's something to keep in mind. If you're doing in Washington, we usually still do a standalone louver and then something like a VCD-23, the low gauge damper that everyone's familiar with.
Completely agree with you, Chris. We also have a couple of options on our higher volume louvers to sleeve the louver and damper together in the factory. It's definitely something to explore out in Washington if you can't use a combination louver damper. Alrighty. Beyond wind-driven rain, how do you know if you need a severe duty louver? So very briefly touching on severe duty louvers, let's talk about if you need them. Our severe duty louver product offering includes high wind load applications, impact ratings, Florida product approval, Miami-Dade ratings, and tornado rated louvers. The Miami-Dade rated louvers will satisfy international building code requirements for the hurricane-prone region, which is going to be in orange on the map here. The hurricane-prone region is defined by the International Building Code as the United States Atlantic Ocean and Gulf Coast, where the ultimate design wind speed for a risk category 2 building is greater than 115 miles an hour, and all of Hawaii, all of Puerto Rico, Guam, Virgin Islands, and American Samoa. They'll all fall within the hurricane-prone region. The International Mechanical Code states that if you're located in the hurricane-prone region and using a louver to protect intake or exhaust openings, the louver must comply with AMCA 550, which is going to be a test standard for high-velocity wind-driven rain. If you're in the hurricane-prone region and within 30 feet of grade, and again protecting an intake or exhaust opening, you also need to comply with AMCA 540, which is an impact test standard for windborne debris. Our AMCA 550 rated louvers will always have AMCA 540 for much more simplified louver selection, just to make it a lot easier for you guys. I really want to take a minute to talk about wind load versus wind speed. We get this question all the time. Louver product is rated by wind load in pounds per square foot instead of in wind speed. You're going to find that across all manufacturers. So the wind speed is going to be the rate at which air is moving horizontally. It's going to be measured in miles per hour or meters per second. But a wind load is a force or a pressure exerted by the wind on a structure, like a building. And it's going to be measured in pounds per square foot or in pascals. So wind speed is only one of the factors used in determining wind load. There's going to be a lot of other factors in the equation. That equation is through ASCE 7. And those factors include the structure, the height of the building, any other topographic features nearby. If the louver's, say, in a corner zone or in the middle of the building, and the angle of wind attack. So if we're asked, hey, I've got a louver that needs 130 mile per hour wind rating, we're not going to be able to answer the question, and nor is other louver manufacturers typically. So we have 3 louver models specifically for high wind load that also meet AMCA 540 impact qualification if you would like them to. While they do have a Florida product approval and hurricane impact qualification, we see these utilized all over the country for high wind load applications because they're good to up to 200 pounds per square foot based on the louver size. A smaller blade span is going to be a higher wind load, so it does depend on size. These louvers do not comply with AMCA 550 for high velocity wind-driven rain, though. So here are the louvers that do. These are our best hurricane louvers, which will have a Miami-Dade notice of acceptance. The EVH 501D is our very best model for performance and ease of installation. Because of these things, it's actually used as the basis of design on large data centers because it keeps out the water while maximizing free area and it's easy to install. The next best protection with the blades fully open is going to be the EHV 550D. That's a dual module louver. It's for those architects that don't always love the horizontal appearance, but it's got the vertical performance and a vertical installation, and it's only 5.5 inches deep. We have a few other louvers that meet AMCA 550, but the caveat is they have to have a factory installed VCD, that's a control damper. And the installation into the building is going to be much more complex. And these should not be used for buildings that will remain occupied during a storm because in order to meet AMCA 550, those damper blades need to be closed. So for hurricane louvers, having AMCA 550 matters most when you're in the hurricane-prone region. And again, if a louver meets AMCA 550, we at Greenheck make sure it meets AMCA 540 to make things easier for selection. Beyond hurricanes, how do you know if you need a tornado-rated louver? Louvers with FEMA 361 ratings appropriate for storm shelters are required in the orange and red zones on this map of the United States that I have here. If you fall under wind zones 3 or 4, again in orange or red, FEMA requires any wall penetration in a hurricane or tornado shelter to comply with test method ICC 500. This is going to be an impact test that's even more stringent than AMCA 540 for the windborne debris in hurricanes. For ICC 500, a 15-pound 2x4 is shot multiple times at the same louver at 100 miles an hour. It's pretty cool to see. It's very destructive. Here are two ICC 500 rated products. The AFL 501 on the left has been around for over a decade, and it's kind of like a grill for tornado shelters. It's best suited for interior walls where no provisions are needed for wind-driven rain, or it's really well paired with like a wind-driven rain louver or maybe a damper on an exterior wall. We are particularly proud of the AFL 601 on the right side of the screen. It was just launched last April. I'm a proud member of the design team for that. I was still in product development engineering at that time. This is currently the only louver in existence that is ICC 500 listed, AMCA 540 listed, and AMCA 550 listed, meaning that it is the only FEMA louver in existence that can meet code when installed on an exterior wall in the hurricane-prone region. Again, we're very proud of this louver. So I'd like to talk briefly about louver installation. We get a lot of questions on this as well. The Miami-Dade NOA, Notice of Acceptance, is going to serve as the installation manual on the hurricane louvers. All the hurricane and tornado installation manuals are going to show anchoring requirements and tables to ensure your product meets what has been qualified by AMCA. On severe duty louvers such as these, it's important to verify that the building substrate being used is one that the louver is actually qualified to be in. As an example, an insulated metal wall panel is not a qualified substrate. It is not going to hold up a louver, but the structure behind that insulated metal wall panel usually is one of the qualified substrates, and the louver could possibly be installed to that instead. For you guys, you're probably going to be using the installation manuals. We also call them IOMs for our standard stationary and operable louvers. They're available online. If you have larger louvers, I highly recommend looking at these installation manuals so that you know if any additional structure is going to be required for your project. The installation manuals will show at what point structure by others is required to support the louvers. Louvers are typically mounted at the load-bearing frame members, so that would mean a horizontal blade louver is going to be mounted at the jambs, and a vertical blade louver is going to be typically mounted at the head sills. Other mounting options, if you're going, single high but multi-wide, or vice versa, maybe you have multi-high louvers, those are all going to be laid out in the installation manuals and show you how to best attach the louvers to your structure. As a general rule of thumb, louvers that are both multi-wide and multi-high are going to require additional structural support to support the louvers. That structural support is by others. It's not by Greenheck. We don't have structural support. Here we show a few examples of what that structure could look like, and this is in our installation manual. If any additional structure is needed on a hurricane or tornado louver, that structure is actually going to need to comply with what has been qualified by structural engineers, meaning the structure needs to be between the louver sections and not behind it like we show in this detail here. There may be a certain appearance that you're looking for on a project when larger louver panels are being utilized. So here I show a visible mullion versus a continuous blade appearance on louvers that are multiple sections wide. Any of the drainable louvers are going to have a visible mullion, like shown on the left, because the jam is needed for the water to drain out. So it acts as a rain gutter, and if it's not present, that water has nowhere to drain to. And all of the severe duty louvers are going to have a visible mullion as well. You can get the continuous blade appearance on non-drainable louver models, like an ESJ 401 is probably going to be the most popular. Your revs at Dorse are also able to provide drawings for the specific louvers on your project. The drawings are going to show the different louver sizes, all the accessories that are selected specifically for the louvers that you're looking at. They're also going to provide helpful details of how multi-high or multi-wide sections are going to be assembled together in the field. So on this last picture I have, this is a multi-high louver, and there's a detail of the alignment plates that attach the louvers at the section split. The drawings will also show the mounting items that are provided by Greenheck and what items are by others. Quick run through of the options we offer as accessories. The items in bold, the flange frames, the extended sills, bird screens, insect screens, and mounting clips can be ordered standard to ship separately from the louvers for field installation. These are really common accessories. Probably the most common is going to be a flange frame. Holes in walls are always perfect, right? So the flange frame is a really great option if there's a little bit of an oopsie in the wall. Extended sills are really great for capturing water or just having a little kick away of water away from the wall so that it doesn't have those lovely water stains over time in the corners of the louver. Bird and insect screens are really great for shipping loose after the fact if you need them, and then any additional mounting clips if you want them. We can also provide specialty shapes. So I have a huge list of shapes here. The most common is usually triangular if it's not rectangular. And then the other item, which we kind of mentioned already after one of the questions, we can do factory sleeve dampers on select models. For specialty shapes and factory sleeve dampers, there's going to be some sizing restrictions on those options, but we can accommodate most requests via an SDR or a special design request. A lot of the limitations on sizes before needing an SDR are going to actually stem around our paint line restrictions or shipping restrictions. So if the louver is mill finish, the largest in one direction is 84 inches before the louver needs to be split so we can ship it. The louver, if it's painted, the sizing restriction is going to be 72 inches, unless you like a louver that's been drug on the floor of the paint line. Most people don't prefer that. Speaking of paint, we have a variety of color and finish options available. Our standard and very best option is going to be the AMA 2605. It's a 70% Kynar, or a 100% fluoropolymer with a 10-year warranty, optional 20-year warranty. The finish contains a Kynar 500 resin that offers excellent color retention, UV resistance, salt spray tests, corrosion resistance, chalking and fading resistance, all that fun stuff. We also can do custom color matches. If you send in a sample of that color, we can have our paint vendor match it for you. Wrapping up, let's talk about another option for a complete product submittal, environmental product declarations. We call them EPDs. Building code compliance and performance requirements should always be a priority in louver selection, of course, but sustainability can also play a part. An EPD is a standardized and verified document that discloses very detailed, credible information about a product's impact on the environment. An EPD follows a life cycle assessment, which is going to be an analysis of the environmental impact on a product through its entire life cycle. That life cycle assessment is also commonly known as cradle to grave analysis. Cradle to grave includes the raw material, manufacturing, construction, and end of life replacement and disposal on that product. So we're aware of only 2 other louver manufacturers who have available EPDs. But both of those manufacturers have created their EPDs to cover a mass of product category in a very vague manner. Greenheck has model-specific environmental product declarations for 28 of our most popular louver models. There is a 29th on the way, that is the AFL 601, that FEMA louver. The EPD includes the impact of our most popular options, which is going to be the AMA 2605 paint and the flat and expanded aluminum bird screen. So where do we find these EPDs? The best ways to find our EPDs are on greenheck.com or smartepd.com. At smartepd.com, you'll navigate the EPD library where you would find Greenheck listed as an owner of the EPDs. This will take you to all 28 of our EPDs that are available for view and download. At greenheck.com, you'll find the EPD document on the product page of the specific louver model being viewed. So there's a hyperlink on the product data pages. That's that static submittal that I was talking about. There it is. Your reps at Dorsey have an additional option to print them from our computer-aided product selection, or CAPS software, to include the EPD in a submittal package for you. So your reps at Dorsey are really great resources for our louver product. Todd, Paul, and I are also here to assist you if you ever need us. I just ran through a ton of information in a very short amount of time. So what questions do you have for me?
Well, we do have one that is in the chat. Is there a recommended straight duct length after a louver, or a length of duct before an electrical component downstream of a louver, specifically thinking of marine applications? I know we talk about often when you're ducting, find a louver to have it slightly sloped back towards the louver. That way it can drain out the sill. Is there any recommendations there?
We don't have any kind of formal recommendations since the duct is not by Greenheck. We were asked fairly frequently on if we can provide details of how that duct interfaces with the louver, but because that duct isn't something we provide, we don't always have a ton of information. We pretty much say exactly what you said, Chris. You know, we recommend a little bit of a slope just so it's not perfectly flat so water can kind of egress. We don't have any, length or angle recommendations.
Yeah, if you've ever seen testing with these, if you select your louver appropriately, you should be in good shape. There's always the chance of getting some moisture through. When in doubt, use that wind-driven rain louver, slightly oversized to get that velocity down. But in a critical application, I would imagine if you have a few feet or maybe the equivalent height of the duct in terms of length sloped back, obviously every architectural space would make a difference, but the key is to have a little bit of duct slope back. If there's anything that, if the louver was magically, above a generator or a circuit breaker box, I can't imagine that being the case, but there's something to contend with.
Yeah, it's very often that people forget that louvers are holes in walls. And then they're, if water does get through, they're shocked by it. Selecting a louver appropriately really, really helps. But if you get a once in a century kind of storm, you may get a little bit of water. So having that slope duct is great.
Or potentially having a damper behind in case you need to close it, add one extra level during that.
Sill pan. Yeah, there's a lot of things.
So something to keep in mind, as Morgan's gone over all this information, and we've talked about all the ratings, the velocities, the beginning points of water penetration. You can select your louvers in desktop caps, the full version of caps, and in eCaps. ecaps.greenheck.com. It's great selection software to, enter, your length and your width and your velocity and return a pressure drop. Or maybe you have a known volume and you want to keep it below 500 feet per minute, and it'll give you several different models at several different dimensions and give you budget prices to compare. Obviously at Dorsey, myself and Scott Boucher and Blake Bonham, we are happy to assist on the engineering side. For those of you who work with contractors, you have your account manager who can help with that as well. we're one big Dorsey team, and we're here to help get you the right louver. And I noticed a few names that have been viewing today have actually been up to Greenheck, and they've seen the really cool louver display.
Yeah.
And there is a mini water test that you can put your eyes on and see with little mini 3D printed versions of the individual blade types. So you can see how a wind-driven rain might do better than a standard blade louver. So it's a pretty cool little demo. I always like that one. It's really surprised me. You actually see the water blowing against those louver types. So that's another thing. We are happy to do trips to Greenheck, and it's more than just the louvers, as you know, with everything Greenheck has, but the louvers are a fun part, and maybe Morgan or one of her counterparts will present to us.
Yeah, absolutely.
So with that, we'll hang around for a couple more minutes, and feel free to put some questions in the chat. This presentation has been recorded, and when I do some editing magic, we will post it on our YouTube page so you can reference it. So we'll just stick around. So thank you, Morgan.
Thank you, Chris. Appreciate the opportunity. And I'm looking through the chat, and I love you guys were very engaged in asking questions. That's awesome.
I've done some work in the Southeast, so I'm very familiar with the hurricane prone region and the Miami-Dade and Florida approved requirements.
Yeah. We like to educate it on it as much as possible, given this region. I just still wanted to touch on it because sometimes I ask someone, say in coastal Texas, hey, are you in the hurricane prone region? They're like, oh, I've never seen a hurricane. And I'm asking if you're in the hurricane prone region as defined by the International Building Code. And they normally have no idea. So we like to educate it on as much as possible.
Yeah, stretching from Texas to Maine, right?
Yes, many people are in the hurricane prone region and they don't even know it.
Yep. All right. Well,
Hey, Morgan, this is Scott with Dorsey. You mentioned the environmental protection declarations. Now, is there some kind of national standard for that? How is that based?
Environmental product declarations normally have to do with like LEED credits is where we mostly see them. They're not on every project. On really big projects, we see them used a lot more frequently. We see data center requirements for them as well. Normally because those specific companies are so large that they do truly have a very big impact on the environment around them. And there's regulations in place for that. I'm not as well versed in those specific regulations. I do know from the sustainability requests we've seen, it's usually to satisfy LEED credits. So credits you could get for having an environmentally friendly building project. I believe it's from the government.
Okay, got it. Thank you.
Yeah. I'll get a little more well versed on that, and I might send you a little bit of a better reply, Scott.
Sounds good.
All right.
All right. So with that, hopefully everyone realizes that louvers are more than just a hole in the wall, even though it is a hole in the wall. And there's no way we expect anyone to remember every blade type, every performance rating. Our job as your Dorsey rep and Morgan's job as an application engineer at Greenheck is to be able to support you no matter what the project is. So just ask the question. Contact your Dorsey, sales support or engineering support or your account manager, and we'll get it handled for you. And if we can't figure it out, we'll get with Morgan and her team. All right.
Thank you guys again so much. Really appreciate the time you took today to learn about louvers.
Thanks so much. We'll see you all hopefully next week. Bye.